Hello friends, welcome back my YouTube channel MS Maths. In this video, we are going to discuss about previous year question of 20 plus years of GATE Engineering Mathematics Mechanical Engineering branch. So we'll discuss ordinary differential equations question and my name is Manoj Solanki and I'll start the video of ordinary differential equations. For the one short video, you can visit my playlist in which I have explained the concept of ordinary differential equation in a single video. So let's start the question from 2025. Okay. So basically, first question is from 2025 GATE 2 marks question. Okay. So in this question, they have asked about the let y be a solution of differential equation with the initial conditions given below. If y at x is equals to 2 is equals to a log of 2, then the value of a is rounded off to decimal places. And this is the differential equation x squared d2y by dx square plus 3x dy by dx plus y is equals to 0. And these are the conditions. So for this differential equation, whenever you will have this kind of differential equation of x square y double dash plus 3x y dash plus y is equals to 0. And the conditions are y at 1 is equals to 0 and 3x y dash at 1 is 1. Here, for this differential equation, first of all, this is a particular type of differential equation is called Cauchy-Euler differential equation, in which we will just replace x with e to the power of z. It means here we are going to differentiate. If my d is d by dx, then d dash will be d by of dz. So your x square here, your x square y double dash is nothing but d square or x square d square. It is what? It is nothing but x square d square and it will be replaced with d dash minus 1. And similarly x y dash is nothing but okay x into d will be replaced with d dash. So your original equation will be basically this is the coefficient, this is the variable coefficient differential equation, and now we are converting it into a constant coefficient differential equation and it will be homogeneous because the right hand side will be 0. So now the differential equation is nothing but d dash of d dash minus 1 plus 3 is as it is, and it will be d dash plus 1 of y. Okay, and this differential equation will be d dash square minus d dash plus 3d dash plus 1 of y. Now the auxiliary equation will be nothing but, or after solving this is d dash and this will be 2 of d dash plus 1 of y. Now the auxiliary equation, we are going to replace this d with m or this d dash square with m square. It means it will be m square plus 2m plus 1 is equals to 0. Okay. So after solving this is nothing but m plus 1 whole square is equals to 0 and roots are nothing but minus 1 and minus 1. So in this case, my solution will be, remember this thing. Now this differential equation is nothing but this is what? This is in terms of z, this is with respect to z. It means this is nothing but d2y by dz square plus 2 dy by dz plus y is equals to 0. This is the case of constant coefficient differential equation. We can easily solve this kind of differential equation whenever we will have right hand side 0, then the solution will be y of complementary function. Otherwise, we will have to find also the particular integral, but here it is 0 because right hand side is 0. Now, the complementary function for this case, whenever you will have both equal root, then the complementary function y of c is nothing but c1 plus c2. Now, it is what? The independent variable is z. So, it is z. Don't write x here. Okay, z and then e to the power of minus z. Now, again, what we have considered initially that x is equals to e to the power z, it means my z is equals to log of x, and I will just repeat, I will put it here, and it will be c1 plus c2 log of x, and it is nothing but x to the power, we can like write it as e to the power of z, then we can write it as e to the power of, or nothing but x to the power of minus 1. Okay, here this is the solution of this original equation. in terms of independent variable with x. Now the condition is given here, or I can write it as y1 by x, and it will be x plus c2 log of x. This is the general solution. Now we apply the conditions, that is nothing but this and this. So the first condition is that at x is equals to 1, my y will be 0. So left hand side will be 0, and it will be 1 upon 1 c1 plus c2 and log 1. And you know the log 1 value is 1. So it means that my c1 is nothing but 0. So now my solution will be, now from here, my solution will be y is nothing but c2 into log of x upon x. Okay, c1 is 1 here, so c1 is 0, and this will be my general solution. Now we are going to apply the second case. For that we have to differentiate this one. So the derivative become, here if we are going to differentiate this one, then the derivative, so y dash is nothing but, to calculate the derivative we have what, c2. Okay, first one is that we are going to apply that it is nothing but c2 into 1 by x, and it is nothing but log of x. It is what, u, and it is what, v. Now here if we are going to differentiate with respect to x, it means that we will first differentiate 1 by x, that is nothing but 1 upon x square log of x as it is, plus here 1 by x will as it is, log of x will be here. So this is the differentiation. So now the differentiation is y dash, okay, and it will be c2 into minus log of x upon x square plus 1 upon x square. Now it is saying that after multiplying this equation with 3x at x is equals to 1, this value will be 1. Okay, now here this value will be 1. So I'm just writing here, it is nothing but if I will multiply this thing, 3x y dash is nothing but c2, and if I'm going to multiply this x with here, then it is nothing but 3 log of x upon x, because one x will be cancelled, and this is nothing but 3 upon x. After that, at x is equals to 1, this whole value will be 1, and then c2, and this whole value will be 0 because log 1 is 0, and this will be 3. So now from here, my value of c2, wait just a minute, if I'm going to multiply with this, okay, and y dash will be this, okay, then c2 will be 1 by 3. Okay, from here if I'm going to multiply with 3x, and of course it will be, okay, c2 will be 1 by 3. And after finding this c2, what we have, the general solution is nothing but, I am just removing this part from here. Okay, what is my general, or what is my particular solution for this particular case? So this will be y is equals to, c2 is 1 by 3, then it is nothing but 1 by 3 into log of x upon x. On putting in this particular equation. Okay, here it is saying that at x is equals to 2, at x is equals to 2, it is nothing but a log of 2, okay, is equals to, this is 1 by 3 log of 2 upon 2. Now this will get cancelled. Now the a is nothing but 1 by 6. This is your correct answer. So this is the correct way of this particular equation. Okay, or just let me check it again, is 2. Okay, okay, c1 is correct here, and the differentiation is nothing but c2, and it is c2 1 minus log upon x square, and if I will multiply with this, it will be minus of 3, and it will be, of course, 3 by x will be there, and it will be, if I'm going to put 1 here, then it will be 3. Yeah, so this will be the correct answer. So a is nothing but 1 by 6 for this particular question. Now let's move to the next question. This is the 2024 question in which, okay, if x of t satisfies the differential equation, and it is given that t d of x by dt plus t minus of x is equals to 0, subject to the condition that x at 1 is equals to 0, then what is the value of x2? Okay, first of all, this is nothing but a first order differential equation, and if I'm going to write it as d of x upon dt is nothing but okay, one thing is that if I'm going to divide this thing here, then this will be dx by dt plus this is what 1 minus x upon t is equals to 0. Okay, and this is nothing but dx upon dt minus x over t, and it will be minus 1. Okay, this is what, this is linear differential, linear first order differential equation, or this is what dy by dx plus p of x y is equals to q of x. Okay, this is the case. So the solution is what, y into integrating factor and then integration of right hand side into integrating factor d of x plus c. But see here, my y is x, it means dependent variable is x. So what is that? The integrating factor is nothing but e to the power of minus 1 by t of dt, and it is e to the power of, basically the integrating factor here is nothing but integration of p of x with respect to x. So now it is nothing but log of t, and this will be 1 by t here. So my x into integrating factor, that is 1 by t, is equals to, okay, and right hand side is minus of 1 integration with the 1 by t dt plus c. So it is x over t, and it is minus of, and it will be, okay, the integration of t power minus 1 dt plus c, or sorry, it will be log of, basically it will be log of t. Once a second. Yeah, it is nothing but minus of log t plus c. Now here what can I do? So it is x of minus t, and it will be log of t plus c. Now I have my initial value problem, that is what, x at 1 is equals to 0, and if it means I will put t is equals to 1 here. If t is equals to 1, then it will be 0. So t, okay, yeah, 1 log of 1 plus c, this will get 0, then my constant, arbitrary constant will be 0. If my arbitrary constant is 0, then the solution is minus t log of t, and it is saying that what is the value of x is equals to minus 2. Okay, it is minus 2 into log of 2. So after finding the value of log of 2, it is nothing but minus 1.4 to minus 1.38. In between this will be the correct answer after rounding of 2. Okay, now move to the next question. Consider the second order linear differential equation. Okay, this is again a Cauchy kind of differential equation in which we are going to replace this with this derivative. So I'm just writing it as m minus 1, the concept I have explained earlier. Okay, now it is just 1, then I will just write m minus of 1 is equals to 0. Now it is nothing but m square minus m plus m minus 1 is equals to 0, then it will get cancelled. So m square is equals to 1. So my m is nothing but plus minus 1. So what is the solution in this case? So the solution y is nothing but c1 plus, or c1 e to the power of z, okay, plus c2 e to the power of minus z, okay, 1 into z and minus 1 into z. So basically this is the solution case here. So if it is a solution, then I will just replace my z is equals to log of x. So it is nothing but c1 into x plus c2 upon x. Okay. So here, so y is nothing but this. So now my initial condition, or the initial condition is given here. So at x is equals to 1, it is 6. So if I will replace this with this, then 6 is equals to c1 plus c2. If I will put x is equals to 1, then this is the one of the equation. And another one is that what is y dash here? So y dash is nothing but c1 plus c2 into minus 1 upon x square. So if I will put 1 here, so this will be 2. So c1 minus of C2. So I have these both equation and I can find the solution, or I can find the value that is basically C1 minus C2. Now from here, I can just find C1 is 4 and C2 is 2. Okay. So these are the constants now. Okay. What is the solution here? So this will be 4 into x plus 2 upon x. This is the solution. Now what is this? What is the value of y at x is equals to 2? Then y is equals to 4 into 2 plus 2 upon 2. Then y is nothing but 8 plus 1. So the correct answer is 9 here. Okay. Now come to the next question. Okay, this is the question in which for the exact differential equation. What is the exact differential equation? Whenever you will have this kind of differential equation, mx plus n dy is equals to 0. If my partial derivative of m with respect to y and partial derivative of n with respect to x is equal, then the differential equation will be exact differential equation. And the solution of this differential equation is m of dx, where y is equals to constant, plus n of y is equals to 0 without without x term. There should not be term of x. Now here, don't get confused with this. It is what? Du by dx. So my x is what? U, and my y is what? X. This is the confusion here. So what is the solution here? So this is nothing but du into 2 plus x square into u, okay, plus x into u square d of x is equals to 0. So this is my m. I will consider it as m, and this will be my n. So is it a exact differential equation or not? For that, what I will do, m with respect to x, partial derivative of m with respect to x, okay, another variable, that is nothing but this. So what is the partial derivative? This is nothing but 0 plus 2x into u, okay, and similarly n with respect to another variable, that is u. So it is nothing but 2 of x. These both are equal. It means it is an exact differential equation. Okay. Now the solution is m du without, this is without, oh sorry, this is constant, taking the constant of x. Here my another variable, that is x, and that will be constant here. And similarly n of dx, where without u, without another variable, and it will be constant, not 0, it will be constant. So it is nothing but 2 plus x square into u plus, okay, yeah, it will be with respect to u, and this will be here what is without u term, but in this case u is involving in this part, so it will be 0 dx is equals to c. So this will be 2u plus x square will be as it is, and this will be u square by 2 is equals to c. Then what is the case here? Then what is the solution? Basically 1 by 2x square u square plus 2u is equals to c. So this is the correct answer. Where is it? So the 1 by 2 x square, the c will be the correct answer. Next. In the next question, we have considered the differential equation. It is what? 3y double dash plus 27y is equals to 0. With initial condition, y is equals to 0 is equals to 0, and y dash of 0 is 2000. The value of y at x is equals to 1. Simple. Whenever you will have this kind of differential equation, just find the homogeneous part, because right hand side is 0. So the homogeneous part case will be complementary function. This is the solution. So for that, we are just replacing with m square, with m. Okay, so 3m square plus 27 is equals to 0. Now it is what? M square is equals to minus 27 by 3, and it is nothing but m square is minus of 9. Okay, if it is minus of 9, then what will happen? 1 second. Yeah. Now here, what will happen? My m is nothing but 3 plus, okay, yeah, plus minus 3 iota. It is nothing but plus minus 3 iota. Then what is the solution in this case? Whenever you will have m is complex number plus minus iota beta, then it will be e to the power of alpha x c1 cos of beta x plus c2 sine of beta x. Okay. So here my alpha is 0, then this thing will be 1. So my solution will be, okay, yeah, solution will be, 1 second, yes, y is nothing but c1 cos of 3x, okay, cos of 3x plus c2 sine of 3x. Here it is what? 0 is equals to 0. If I will put x is equals to 0, then 0 is equals to c1 cos 0 will be 1 and sine 0 will be 0. It means my c1 is 0. Okay, if c1 is 0, then my solution will be c2 into sine 3x only. Okay. After that, what is the value of c2? For that, we have to calculate the derivative of this. What is the derivative? Y dash is nothing but it is what? c2 into cos of 3x into 3. So now, if I will put 0 here, then it will be 2000 is equals to 3 c2. Okay. Cos of 3. So after putting the value, we'll get some c1 here. So this is nothing but 2000 divided by 3 into cos of 3. Okay, I have not exact calculation for this. So this is your c2. After calculating this, you will get, after calculating this c2, if you will put with this, y is equals to 2000. Oh, wait 1 second. Y is equals to 2000 upon, put in this equation, okay, 3 cos of 3 and it will be sine of 3x. Now what is this? At x is equals to 1. So this is what y is equals to 2000 by 3 and it will be tan of 3. So after multiplying this, you will get 94.08 after calculating this. Okay. So this is the solution for this differential equation. Next, a differential equation y double dash plus 16y is equals to 0 with the boundary condition given at x is equals to 1 and pi by 2. For this case, we'll just find the auxiliary equation. It will be this, and now it is nothing but m square minus 16. So my m is nothing but plus minus 4 iota. So the solution will be y is nothing but c1 cos of 4 of x, okay, plus c2 sine of 4x. Now the boundary condition is y dash on y dash. So first of all, I will find y dash. Y dash is nothing but c1 sine of. Okay, so the derivative is minus sine of. So it is nothing but minus of c1 sine of 4x into 4. And this will be c2 cos of 4x and 4. If I will put 0 at x is equals to 0, my y dash is 1. So it will be 1 minus of c1. So sine 0 will be 0, but c2 and cos 0 will be 4 into 1. Okay. So 1 by 4 is nothing but c2. So your c2 will be 1 by 4. The thing is that it is asking about no solution, exact solution, and this. So for this case, we'll just try to find the solution. This is my C1. So here, if I will, with this boundary condition, okay, so this is my C2. If it is my C2, then I will just calculate C1, or basically I will just find one thing is that if my C1 is 0, okay, for here it is, now y dash is nothing but minus of c1, okay, cos of 4x into 4, and my c2 is 1 by 4, that will cancel with this 4 cos of 4x. So it is nothing but y dash is equals to minus c1 cos of 4x. Oh yeah, it is not 4x, it is sine of x. So sine of 4x into 4 plus this will be cos of 4x. Now here it is what? Pi by 2. At x is equals to pi by 2. At x is equals to pi by 2, it will be minus 1. So it will be minus 1 minus c2 sine pi by 2. So 4 into pi by 2. So this is what? 2 pi. Again, sorry, this is 1. Again, this will get 0. Again, this will get 0, and it is what? Cos of 4 pi by 2, and it will be 2 pi. So what is the value of cos 2 pi? Cos 2 pi is 1, but it is saying that cos 2 pi is minus 1. It is equating, but it is not equal. It means it is not satisfying this condition. If it is not satisfying this condition, then it has no solution. Of course, we can't say the solution will exist for this differential equation or not. So this is at no solution. Next question. If my y is equals to f of x satisfies the boundary value problem, then what is the value of this? So this is simpler. M square plus 9 is equals to 0. Then my m is nothing but plus minus 3 iota. Then the solution will be c1 cos of 3x plus c2 sine of 3x. Okay. The condition is given that y0 is equals to 0. It means it is 0. Then c1 cos 0 is 1, but sine 0 is 0. So my c1 is nothing but 0. So the solution is c2 sine 3x. Now my y pi by 2 is root of 2. So it is what? Root 2 and y pi by 2. So c2 sine 3 pi by 2. Sine 3 pi by 2 is minus 1. So my c2 is nothing but minus of root 2. If my c2 is minus of root 2, then what is y? Minus of root 2 sine 3 of x. Then my y is nothing but minus root 2. Okay. So it is minus root 2 sine 3 pi by 4. And the solution for this case is minus root 2, and it is again minus 1 by root 2, and this will be y, okay, plus 1 by root 2, sorry, plus 1 by root 2, and this will be the minus 1 by minus 1. So the correct answer is minus 1 for this question. Next case. Consider the following differential equation dy by dx. It is what? Dy by dx is equals to, sorry, dy by dt. Okay. So it is dy by dt minus of 5y. So here the initial condition is given that y at 0 is 2. Then what is the value of y3? This is to be asked. So it is simple. We'll just calculate dy by y, and it is minus 5 of dt. It is variable separation method, and it is log of y is equals to minus 5t plus log of c. If it is in a log form, then the constant will be in the log form. It will be easy to calculate. So it is nothing but log of y by c. If I will take here, then it will be minus the log m minus log n will be log m by n. Okay, and it is minus 5 of t. So my y is nothing but c to the power minus 5 of t. Now here it is what? The given thing is that, one thing is that, what is this? T. So if I will put t, then it will be c e to the power minus of 15. So now here it is what? What is the, if it is 3, okay, and it is 5, then it will be 15. So no need to calculate the value. So the c will be the correct answer in this case. Next. Or otherwise you can put this condition here, and you will get exact c is equals to 2 and exact the answer. No need to calculate that. Next. So the next question is 2015, that is find the solution of d2y by dx square y which passes through the origin. It means one of the thing is that y0 is equals to 0, and another thing is that y at log of 2 is equals to 3 by 2. It is satisfying the thing. Okay. So it is what? My m square minus 1 is equals to 0. It means my m square is equals to 1. So m is nothing but plus minus of 1. So it is nothing but c1. Okay, y is equals to c1 e to the power of x and c2 e to the power of minus x. So these are the conditions here. If it is satisfying this thing, so you can satisfy, like you can check whether these conditions are satisfied by the solutions or not. First, it is what? If I will put 0, 0 here, then this will be, okay. If I will put 0, 0 here, then this will satisfy. This is what? Y is 1 by 2 e to the power of 0 minus e to the power of 0. If this will be 0 or not? Yes, it will be 0. This will be satisfied. this will not be satisfied because this is 1 plus 1, and again this is like this will also be satisfied, but the thing is that this one and this one is the same. Okay, there is a problem here. So the correct answer is, see, one thing is these both are same, so these both will correct and this is not correct because the answer, there's a misprint in the question. So you can check whether this, or you can solve, or you can apply these both condition here. So this is the simplest case. You can just discard the option. Next, uh, this is the question related to first order differential equation, okay, in which we have y dash is equals to minus 2xy, and it is, and given that y0 is nothing but 2. So of course this will be dy over y, and it will be d of x, okay, minus 2x into d of x, and this will be log of y is equals to minus 2 of x square by 2, and this will be log of c. So it is nothing but y over c, and this is minus of x square. So y is c, or minus of c e to the power of x, sorry, c e to the power of minus x square. Now here it is what, c e to the power of minus x square is only, the answer is B. Okay, next, no need to apply the condition. If y is equals to f of x and is the solution of this, then what is the case here? If my second derivative is 0, it means that if my second derivative is 0, or I will just separate, then d2y is 0. It means that if I will differentiate this one, then this will be dy. It means it will be a constant. Okay. Again, if I will differentiate y, and of course it will be d, and it will be x. So this is the curve here. This is the solution of this differential equation which will satisfy this. The boundary condition is given that boundary, okay, yeah, 1 c1 plus c2 will be there, yes. Or if I will write it as here, then my m square is 0, so my m is 0 comma 0. So the solution will be what, y is equals to c1 plus c2 into, if because of that it is a repeated root, then I will just write c1 and c2 into x e to the power of 0x. So the same thing will be here, you can find in the like any kind of thing. Okay. So here y is this. So if my y is this, then I can put the condition here. Then y is equals to c1 plus c2x. So y is equals to 5 at x is equals to 0. If my x is equals to 0 and it will be 5, then c1 is nothing but 5. And similarly, my y dash is nothing but c2. So it is what? 2. At x is it will be 2 at 10, whatever the value of x, no effect of this, then c2 is nothing but 2. So y is nothing but 5 plus 2 into x, and then what is the value, what is the function, or if it is a function of x, then what is the value of this? It will be 5 plus 2 into 15, it will be 35. So here it will be 5 plus 30, and the 35 will be the correct answer for this question. Okay, next. Okay, the matrix form of the linear system of differential equation. This is the, if it is a linear system of differential equation, then the simple thing is here. Just write it as dx over dt. Then this is what, 3x minus 5y. And it is a dy over dt. And it is what, 4 of x plus 8y. Whenever you will have this kind of system and asked to be to write in a simple differential equation or the matrix form, just simple. This is what, the write the coefficient 3, minus 5, 4 and 8, and it will be x and y, and of course it will be d of x by dt, d of y by dt. Oh, because of that this is the derivative, then you can write d by dt here, then this will be x and y, and the same thing. So what is the matrix? So for 3 minus it will be 3 minus 5 4 8, 3 minus 5 4 8, this will be the correct answer. Okay, next question. Now here you have considered the differential equation. This is simple dy over d of x, and 1 plus y square into x we can separate. So it will be 1 plus y square, and it will be x into d of x. From here you can solve. It is nothing but tan inverse of this is nothing but a tan inverse of y, and this is your x square by 2 plus c. From here y is nothing but x, or tan inverse of x square by 2 plus c. So the correct sorry, it is not tan inverse. If we'll take inverse or the tan both side, then this will be the answer. So correct option is the D. Now the next question is related to the Wronskian. And what is the Wronskian basically? Whenever you will have this kind of differential equation in which y double dash plus y dash. Okay, see, whenever you will have this kind of differential equation in which it is what a0 of x y double dash plus a1 of x y dash, okay, and a2 of x y is equals to 0, then the Wronskian of this is calculating through the Abel formula, that is w naught e to the power of minus a1 upon a0 dx. Okay, but here see, what is the value of a1? It is 0. Then w is equals to w naught e to the power of, this is what w naught is nothing but the Wronskian at x0, or basically at the initial point. What is the initial point is here, it is 0. Then it will be 0 of dx, then simple, this will be w is equals to w naught. Now you have the value. So my wt is nothing but x of x1 of t, x2 of t, okay, x dash 1 of t, x2 dash of t. If I will put 0 here, this is nothing but my w naught, and the value are given. It is 1, it is 0, it is 0, it is 1. So what is the determinant of this is nothing but 1. So my correct answer is 1. Okay, so this is the simple formula for this question. Okay, this is the second order differential equation. What is given to you? This is nothing but u double dash minus of k u dash is equals to 0. So it is nothing but m square minus k m is equals to 0 is given to you. So here k is your constant. So I can take m common, then this will be the factor of this quadratic equation. So my m is equals to 0 and m is k. So the solution will be what? C1 y is equals to, or u is equals to, because basically your solution will be in the form of u. So your u is equals to C1 e to the power of 0 x plus C2 e to the power of kx. Now here it is showing that it is given to you the boundary condition. Okay, at x is equals to 0, my u is equals to 0. So u is equals to C1, okay, plus C2 e to the power of 0. It means u is equals to C1 plus C2. And the thing is, at x is equals to L, it will be capital U. So it will be capital U, and C1 plus C2 e to the power of k into U. Okay. So you have these both equations. What are these? C1 plus C2. It is 0 given to you. Sorry for that. It is 0. C1 plus C2 is equals to 0, and C1 plus C2 e to the power ku is k capital L. Sorry, it will be L. So the value of x is L. Na? Okay. It is given to you capital L. Now if I will subtract, then this is nothing but C2 1 minus e to the power k into L is minus of u. Then what is the value of C2 is nothing but minus u upon 1 minus e to the power k into L. If it is C2, then what is this? C1 is nothing but minus of C2. So my C1 is u upon 1 minus e to the power k by L. So after solving this, we will get, this is the answer, because this is what we can write it as these, this and this. And if we will put this C2 and C1 in this equation, we will get the solution u as option B. So the correct option is B. Next question. Consider the differential equation x square. This is again a Cauchy differential equation. Okay, in which we will just replace, if it is the differential equation, then we can write m minus 1 plus this is what m minus 4 is equals to 0. Then this is my m square minus m plus m minus 4 is equals to 0, then this is nothing but m square is equals to 4 and m is plus minus 2. If it is plus minus 2, then my y is nothing but c1 e to the power of 2x plus c2 e to the power of minus 2. It is not in the form of x, it is in the form of z because we are solving the Cauchy differential equation. Then it is what? I am going to replace my z with log of x, then it is nothing but c1 of x square and c2 upon x square. So from here we have the condition is what? Y0 is 0 and y1 is 1. So first one is 0 is equals to c1. Okay, one thing is that if I will put 0 here, then this will make trouble here. No? So it will be m square minus m plus m minus 4. There is a problem with this question. If I will put 0 here, then this will, okay, this is the mistake. Because of that, if I will put 0 and this will be c2 upon 0, this will not satisfy the thing. So this is the misprint in the question. Okay, next. So this is the differential equation, which is d cube f over d eta cube plus f upon 2 d2f over d eta square is equals to 0. Here it is saying that it is a second order non-linear. Okay, it is saying, asking about the linearity and the order of differential equation. First of all, here f is nothing but any kind of function of eta. So it means it is my dependent variable and it is my independent variable. So whenever the independent variable or whenever the dependent variable, it means y, will be multiplied with its derivative, then it will be non-linear case. So here it is what? F is multiplied with this d2f over d eta square. It means this is the case of non-linear. So third option is not correct. Now what is the order of differential equation? Order is that highest order derivative present in that equation. It is third. So second is not correct. Is not correct. So the B answer is correct. Third order non-linear differential equation is given here. Next question is that it is a differential equation x y dash plus y is x power 4. I can write it as y upon x and it will be x cubed. This is the simple linear differential equation. I will find integrating factor, that is 1 by x of dx. It means log of e to the power log of x will be here, then this is nothing but x. So this is my integrating factor. So the solution is y into integrating factor, and the right hand side is what? X cube into integrating factor dx plus c. Then this is y into x is equals to x power 4. Then it will be integration x power 5 by 5 plus c. And the given thing is that it will be 6 by 5 at x is equals to 1. Okay, 1 by 5 plus c. So now from here 6, okay, 6 is equals to 1 plus 5 6 5c. Okay, if we'll take the LCM, then this will be 5 is equals to 5c, then my c is nothing but 1. If my c is 1, then my y is, okay, y into x is x square 5 by 1, then my y is nothing or not x square x power 5, y is x power 4 upon 5 plus 1 by x. So this is the correct answer here. So A will be the correct answer for this question. Next. Okay, this is the again a differential equation. Double dot means x double dash, double derivative 3x is equals to 0, given that x0 is 1 and x dash 0 is 1. So simple, it is m square plus 3 is equals to 0. It means m is equals to plus minus root 3 iota. Okay, then it is what? C1. Y is nothing but C1 cos of root 3 x. Oh, yeah, root 3t. If it is x given here, then it is x and it will be t plus C2 sine root 3t. So given is that at t is equals to 0. So if t is equals to 0, then x is equals to 1. So C1 cos 0 is 1, sine 0 is 0. So my C1 is 1 here. And the same case here, if I will differentiate this, if I will differentiate this, then this will be x dash, okay, is nothing but c1, and this will be minus of sine root 3 into t, and it is root 3, plus this is what c2, okay, this is c2, and if I will differentiate this, then c2, it will be cos of root 3 into t, and root 3 will be here. Here, if I will put at t is equals to 0, this will be 1. So t is 0, it means sine 0 will be 0, and this will be here. So c2 into root 3, and it will be 1. Cos of 0 is 1. So my c2 is 1 upon root 3. So c2 is 1 upon root 3, c1 is 1. So after that, if we will put here, then my x is nothing but cos of root 3 to t plus 1 upon root 3 sine of root 3 into t. If I will put t is equals to 1 here, then it is nothing but x cos of root 3 plus 1 upon root 3 sine of root 3. If you will calculate the value, you will get 0.41 will be the correct answer for this question. Next. So the next question is related to the second order differential equation, constant coefficient. It is m square plus 2m plus 1 is equals to 0. It is nothing but m plus 1 whole square is equals to 0. So my m is nothing but minus 1 and minus 1. So y is equals to c1 e to the power of, yeah, we can write it is a like a double root, means repeated root. So that c1 plus c2 x e to the power of minus x. So here we have given the boundary condition. It is what y0 is equals to 0. It means it is 0 is equals to c1 plus c2 into, yeah, 0, and it is e to the power 0. So it is nothing but my c1 is 0. So here my c1 will be 0, and at x is equals to 1, it will be 0. So 0, and my at x is equals to 1. So put x is equals to 1 here, and c1 is again c1 is already 0. So it will be c2 e to the power of minus 1. Then of course my c2 is again, okay, wait, here it is a problem again. It is saying that y1 is equals to 0. Okay, if my y at 1, then c1, it will be 1. There is a problem. If it is a dash here, then it will be correct. There is a mistake, because at the same case, at y is equals to 0 and y1 is also 0, this will not be satisfied, because my c1 is 0 and c2 is 0. Oh yeah, one thing is that if these both are 0, okay, if it is correct, sorry, there is an option in z, there is an option of 0 also here. If these both are correct, then my y is 0. Okay, yeah, so the A answer is correct in this case. Correct. Next case. This is what one of the important question which is given whenever you will have this kind of thing, y square, and this is, we will apply the Lipschitz case. So if I'm going to partial differentiate, what is my f of xy? F of xy is y square. If I'm going to partially differentiate with respect to y, then this is nothing but 2 of y. 2 of y is bounded. So this is saying that if it is a bounded, then the solution will exist, but for what case, or for what interval? And the IVP is given that y of 0 is equals to 1 here. See, whenever you will have this kind of question, then just think over it. It is given for x is equals to what? 0, and y is equals to 1 here. So the basically the case is that you will apply the case h, in which we are taking the minimum of a and b by m. This is what, this is basically the we are going to find the interval. Okay, so here my h is what? A. What is a? So case is that my x minus of x naught, that is 0, will be less than of, will be less than of, uh, we can write upper bound of that. It is basically, or y minus y naught is 1, and we are going to consider it as y0 and x0 and y0. Okay, or basically we can write a and b here. If it is a, sorry, but the rectangle will be like this. X minus x naught is up like less than, and y minus y naught will be less than some value. Here my x naught is equals to 0, y naught is equals to 1. If it is less than some value, so here it will be x minus x naught less than equals to a, and y minus y naught less than equals to b. So here my x0 is 1, so it means mod of x less than a, and here it will be y minus 1 less than of b. It means from here the maximum value of x is a and the maximum value of y is b plus 1. So if I will, it will be a and b. What is m? M is nothing but the maximum value of my function. Function is what? Y square. So it is nothing but b plus 1 whole square. And now I will just write a is equals to b upon b plus 1 whole square, and it will be b plus 1 whole square into a is equals to b. Then this will be a quadratic kind of equation. Then a square b square into a plus 2ba plus 1 into a is equals to b. Then this will be b square into a. Okay, and here it will be basically okay, b into 2 of a minus 1 plus a is equals to 0. Here it will be a quadratic equation in the form of b. So from here you can just from here you can just calculate the value of like you can just calculate the value from these both. So after that, after calculating that, we will have an expression in terms of simple a or b, and we'll take the minimum. From that, we'll get the condition. This will satisfy for only this x less than 0 or x greater than 0. Whenever you will have this kind of a differential, like this kind of question in which they are asking about the existence or the initial value problem or the boundedness of this is bounded in this interval. So the solution will be bounded in this interval only. Because of that, if you are going to calculate the solution here, the solution with the calculation of the solution, you can also find this thing. This will exist only when x less than 1 and only when x greater than 1. Okay, this is the case, or this is the one of the way you can also find. For this, you can check my like particular YouTube video for this whole concept. Okay, next. So the next question is related to constant coefficient differential equation. It is saying about the particular integral. So how can you find the particular integral? For that, we will just write it is d square plus 4d plus 3. It is f of d. Okay, and this is nothing but my particular integral is 3 e to the power 2x upon f of d. Okay, so the particular integral is here 3 e to the power of 2x, and it is nothing but d square plus 4d plus 3. What is this? The coefficient of x is nothing but 2. So just put d is equals to 2. So the particular integral is 3 e to the power of 2x. It is what? 4 plus 3. Then it is nothing but 8 plus, wait, 8 plus 3 is 11. 1 second. Is there any problem? D square plus 4d. Okay, 3 to the power x square. Then the particular solution in this case, x e to the power of x. Yes, I will put d is equals to 2 here. Then this will be 4. Oh, sorry, it will be 8. No? So particular integral will be 3 e to the power of 2x, and it is nothing but 15. So particular integral is e to the power of 2x upon 5. So my B is the correct answer. This is the way to find the particular solution. Next case, linear differential equation. Again, you can find easily. So 2 of x y e to the power of minus x square. Then what is the particular integral? But not a particular integral, integrating factor e to the power of 2x dx. Then it is nothing but e to the power of x square by 2. 2 and 2 will get cancelled. So y into integrating factor, and right hand side into integrating factor, this will get cancelled, d of x plus c. So y e to the power of x square, and it will be x plus c. So y is equals to x e to the power of minus x square plus c e to the power of minus x square. And you can just put at x is equals to 1, your solution is 0. So after solving this, this will be 1 plus x e to the power of minus x square will be the correct answer, because minus of x square will be there, not positive of x square. So the next question is again a Cauchy kind of differential equation. Okay, how can you solve this kind of differential equation, and what is the value of complete integral will be there. This is the Cauchy differential equation, and this is your m into m minus 1 plus 2 into m is equals to 0. This is what non-homogeneous case. First we will solve homogeneous only. So it is m square minus m plus 2m is equals to 0, and then this is nothing but m square plus m is equals to 0. So m square plus m is equals to 0. Then from here I can just find m plus 1 is equals to 0, means m is equals to 0 and m is equals to minus 1. These both are the case. So y is nothing but c1 e to the power of 0 z, because we are putting x is equals to e to the power of z and z is equals to log of x. We are just replacing after that. Okay, and this is nothing but c2 e to the power of minus of z. And again, what is this? This is your 2 log of x upon x. But what we have written here, it is nothing but 2 log of e to the power z upon what is x? It is e to the power of z. Okay, this is the case. It is yeah, like this will be 2 and it will be z upon e to the power of z. It means 2z e to the power of minus z. So this will be calculate the particular integral on this case, and after that if you will find the solution, you will get 1 upon e square. This is the hint for this particular question. For this question, the complete solution of ordinary differential equation is what? Whenever you will have this kind of differential equation, so it is a homogeneous kind of differential equation, solution is given that the power of minus 3x. So the root is what? R1, or basically M1 is minus 1 and M2 is minus 3. You can just write M minus or M plus 1, M plus 3. If you will multiply these both equation, you will get the differential equation, and after that differential equation you can easily find P is 4 and Q is 3 in this case. The same question is here. If you will put, this will be y double dash and your P is 4 and it will be y dash, and Q is again 4, y is equals to 0. Now this is what the constant coefficient differential equation, and you can find the solution. Your solution will be this. C will be the correct answer. So the next question is again, it is what? It is nothing but dy by dx is equals to minus of y square, and this will be d upon dy square minus of dx. If you will just integrate this, then you will get the solution y is equals to 1 upon x. So A will be the correct answer for this case. Okay, this is what kind of differential equation is it? Because of that, dependent variable occurs in occurring in a non-linear kind of function, so that it is a non-linear or homogeneous case. Of course, it is a homogeneous, so the two answer will be the correct in this case. I think so. Of degree 2. Degree is 2? No, the order is 2. Is it homogeneous? Yes, it is a homogeneous kind of differential equation, and it is a non-linear kind of differential equation. Okay, so linear is not. So these both may be the correct answer, but most correct answer is non-linear case. Okay, so this is all about the mechanical engineering question of ordinary differential equation. So thanks for watching my video. Keep watching MS Maths. In the next video, we'll discuss some more questions, and for engineering mathematics solution and for gate engineering, you can follow my YouTube channel MS Maths. Thank you.